Yeah, that worked. Thank you. But now I have to share again.
We can see it.
Okay. First of all, welcome very much to this start of a training session for OBI and IDO, and what those two standards are we will come back to later, so you will see what it is. For this meeting we have put down an hour and a half, and that is because we will have an introduction. We will run these meetings every Friday, and then just for 1 hour, not for an hour and a half. So again, welcome everybody. And certainly more people here than I thought would be interested, but that is of course very encouraging for us. There are 3 projects here which participate and which this training session has been developed for. It's the Arrowhead for Flexible Production Value Networks. That is an EU project with some 40 participants, so it's at least in my standard, it's a rather large project. And it is an EU research project. And then there's DISC, which is a Norwegian initiative with Aker BP, Equinor, Aker Solutions and Able participating. And the last project, but not the least, is Integrated Lifecycle Asset Planning, ILAP, which has 4 oil companies. It is a joint industry project with the 4, financed at least by 4 oil companies. And that is about scheduling. So the first we will have an introduction, which I will do to the Arrowhead PVN project, and especially work package 3, which is about major standardized data models. And after that, I will say a little bit about the plan for the training, and then we will have a presentation of DEXPI by Heiner Temmen, who so that is the first of the major data models and standardized standards that we will that will be presented and then discussed. And at the end, we will say a little bit about the further plans for the meetings and the workshops. And please just stop me if something happens, if lost connection or something like that, then you cannot, I will discover. But if you don't hear me, let me know. Or if there are questions, just stop me and ask questions. First, about the Arrowhead PVN project. As I said, it is an EU project, and it's part of a large program in EU to improve productivity. That is the main goal. And for this particular project, it is we say that heterogeneous data models is a bottleneck for improved productivity. So that's where it is we are working in this project. There are 3 industries included: aerospace industry, automotive, and the process industry. And process industry also include oil and gas. We have started out by looking into what data models we should look into and with what standards we should look into, and they are listed here. the automotive work packages, work package or use cases, they are a little bit special. It's much about how to produce things efficiently, talking to machines instead of pressing buttons, and so on and so forth. For the aerospace industry, those standards which are listing here are more familiar to at least those of us who have been working in the aerospace industry. And the same is the case for the process industry. These standards should be fairly well known to everybody that is working in the process plant industries. What we are doing right now in this project, it is decided that we should use semantic analysis and semantic technology to improve interoperability. And the goals which has been set out from EU is to support the cross-industry interoperability framework. And they want to have the interoperability across industries, not just within an industry. And for this particular project, a semantic technology approach is used. And then there are goals about the level of interoperability that we should reach. And the main deliverable is really create a white book with best practices and guidelines. And this training session is the start of that. In addition to the IDO, it's also a training session on SysML, which is good, running in parallel with this. And the expected outcome is to generate analysis of semantic web as an extension to the existing data models. So that is the goal. I'm using this. I took this from one of the use cases, and this is about a digital twin and getting data into the digital twin and out of the digital twin, and there are different standards used for that. It's first from the design and construction systems to the digital twin, and also, of course, data which is needed for the construction, and also going into operation and in operation and maintenance of the digital twin, of the physical twin, and the data that goes into the digital twin, and also to the analysis and simulation systems from the digital twin. And as I already have mentioned, to the operation and maintenance system. So this is one of the use cases, and it is for in the process plant work package, and it is in pulp and paper. And Sweden and Finland, they are strong in this use case. And here is just the standards listed, and you might notice that for the communication between the design and construction and the digital twin, DEXPI is planned to be used or is used. So that is the reason, that is where we start. And the digital twin will be based on the STEP standard, the 10303 standard. So that will be the next one we will look into. But before that, we need to have a presentation of IDO. You can see this. So it will be in the slides, and the slides that will be available for those who participate, of course. And this is just more standards that are being used. And here are the standards organization we have started to work with and made aware of this project and asked for cooperation with, and so far that has been okay and successful. They are interested. In ISO, it's in particular Technical Committee 184, Subcommittee 4, Industrial Data. And certainly DEXPI, which has been mentioned already, and CFOS and PCA, which is the organization I'm working for. That was about the Arrowhead PVN. Any questions before I go to disk? Okay, as I already have mentioned, disk is a cooperation between Equinor, Aker BP, ABLE, and Aker Solutions, and it is about interoperability, just like the PVN project. And it is the goal is to move from a document-centric work process to a data-centric work process. And in particular, the OBI IDO standard is used, and also the IMF information modeling framework is heavily used, and the principle from that standard is coming from ISO IEC 81346 Part 1 and industry standards like DEXPI and CFOS. So there are overlap here, and we are trying to do our best to not duplicate work, but to align work so we can get more, all of us. I don't have a slide for ILAP. That will come later in this. That will be presented later, and then we will have slides for that. I've already mentioned, and in this, for all three projects really, IDO is the top ontology, and this initiative that is training session and also is going to support how to get developed ontologies and reference data for core level for the domain standards, and we even might have to represent industry standards down the road to make this work. So those who are going to create these things, that is what this workshop and presentations are meant for. So then to the training, the objectives is to provide the necessary training for both modeling and subject matter experts to enable the creation of the modules I just talked about. And I also enable the participants to use IDO to develop interoperability between these major standardized data models. And I've highlighted a few of those which we think is probably the more important. At least that is where we are starting. And we need also to clarify the role of the IMF, the information modeling framework, which is heavily used in the DISC project. And we also hope to be able to create an OBI community, not just a community for IDO that exists already, and we, of course, will need to communicate with those who participated there how to develop this further. I mentioned the 3 projects already, so I'm not going to repeat that. Deliverable, we will have at least 3 types of sessions, content session as we call it, the presentation and discussion of the major standardized data models, reference data libraries, and there will be questions and answer session. And in addition to that, we will have practical modeling session in smaller group to address particular issues and try to get solution to that. And originally we planned to start this last Friday. That was delayed, and I have forgot to update this slide, so sorry for that. This is the schedule. The first is this introduction I'm trying to do now, and then there will be a presentation of the DEXPI model. Next week we are planning an introduction to IDO, then a question and answer session to discuss the IDO in connection to DEXPI. And then we have the school break in Norway where we won't have a meeting. And after that it will be the step standard and so on and so forth. So we will come back to what we put in between week 40, between October 19 and Christmas. And we are planning to have continue this next year also if this is successful. So with that, I think I will open again for questions if there are any. If not, I saw Heiner joining, so if you could take over. Let me just show. We have had the introduction. We have presented a plan for the training, and then it's DEXPI. So is that okay, Heiner?
Yes, it's okay. I tried to share my screen. In the moment, it seems not to be possible. Now it's possible, and I hope you can see my screen now.
We can see it, yes.
Yes.
Okay, thanks, Arto. I had to reconnect. There was a hang in my connection, and to start my presentation for today again. I will go into presentation mode. My name is Heiner Temmen. I worked at Evonik for 2 or 3 decades, and now I'm retired. I'm one of the founders from DEXPI, and now have some words to you, Gregor.
Yes. Should I do this myself, or do you want to present me?
Yes, do it yourself, Gregor.
Okay. Yeah. My name is Gregor Tolksdorf. I currently work for Evonik. That is one half of what I'm doing. The other half is I'm very active in DEXPI. I'm the head of the specifications. You will learn about them in a minute. So I'm the one who tries to do the technical information modeling stuff. I'm also part of the CFOS data model team. And I try to relate the information model, the data model that we have in DEXPI to the environment, to other data models, data standards, information models, ontologies. So the topic of ontologies and IDO is very interesting for us. For our small scope that we have, we want to be as compliant as possible to the ontology world, so to say. So we rely to RDL, ISO 15926, we connect to CFOS. That is all, that we look at. And from the technical point of view, I'm the contact person on the DEXPI side for this, for these technical questions regarding information modeling. But the rest you will learn by Heiner.
Okay, in short words, Gregor is my successor in a double way at Evonik and for the DEXPI specifications. I'm still working in the DEXPI networking team, and I will try to explain a little bit more about DEXPI and something around DEXPI. Let us have a look today. First of all, I always start with a view on the life cycle. There are different views on it, and it's important to understand what is our kind of looking for the plant life cycle. Then we go more into details to DEXPI plant and to DEXPI process, the different two specifications. And as Neil said, okay, DEXPI and IDO, we have a special use case in IDO from DEXPI. Let us have a small look at that. And then the DEXPI is a part of the whole process industry community, and we work together, as Gregor said, with CIFOS, and we have an alignment example with CIFOS. I try to go to these agenda points, and let us start with the supply chain and asset lifecycle look on the process industry. We have two main directions. The typical way is the supply chain data model, and the other is in green, the asset lifecycle data model. In the middle, we have an overlap. There is a operation data model, and we concentrate us with DEXPI, let's say, on the green part. The
Heiner?
asset lifecycle data model.
Heiner,
Yes,
could you
yeah.
please click on Ausblenden so we can see the full slide?
Where is Ausblenden?
At the bottom of the slide. Teams is at the bottom, down.
Okay,
Teams,
okay.
yeah. Okay.
Yes, okay. That's the rule from Gregor. He has, in many cases, he has better knowledge than me. Thanks, Gregor. Good. Yes, and then some of us know perhaps the results from the ISO 15926 community with the plant lifecycle model, and there is an important model beginning perhaps with process design. Here we see something, and going to detail engineering, procurement, product specification, let's say to the vendor market, to the products, to the manufacturing, to maintenance, to operation. All these things are covered in this model. And if we have a look, what are the important information structures in this landscape? We see at the beginning there is a world of the, let's say, chemical process with activities like pumping or storing or reacting or heat exchanging or something like that, and the world of calculated streams. Then the next big information structure is about the plant itself. We have a process, and then we have to design in process engineering the first cut of the plant, first with functional and later on with physical objects. In our examples, we have here perhaps the pumping activity, and then we say, okay, how many pumps do we need for this activity? And then we decide we use pumps here as a color blue, and then later on, more in detail engineering, we say, okay, for this kind of pumping, we need a centrifugal pump, and we do technical specification for this centrifugal pump, and then we go to the market, to the vendor market, and have a look at the product catalogs as non-physical objects, and then perhaps we buy one of these products. Then here we have a product which we have bought as owner-operator or EPC, and then we event this as an asset in our owner-operator structure, and we relate this asset to the plant item here. And that is a central view of the plant life cycle, asset plant life cycle we have. Let's say with the important structures, process, plant, the world of the assets, and here is a combination from the types of devices which were on the market and which were bought as products and invented. The same physical things is invented as asset here. That is important. That is our view, and we try always to use these structures. And for the different structures, we have the color in orange, blue, green, and purple and pale blue here. And we will see this in some minutes again. What's about DEXPI, our mission? Our mission is to develop and promote a common data exchange standard for the whole process industry, covering all phases of the process plant life cycle, from the specification of functional requirements to the asset in operation. And we know this is a huge task, and we started with the model for P&IDs, and last year we added a different one, the next one for the process structure with the block flow diagrams and the process flow diagrams. That are the two modules which are specified by DEXPI. And let's say our other big task is that we are part of the networking community, and we work together with the different organizations to get aligned specifications for the whole asset life cycle for the process industry. And we see it today with post-CESA specification, with the different projects which were going on with CIFOS, with ISO 5926, and so on. That is our DEXPI mission. And now let's go to the two specifications we developed in past. And the first in the life cycle view for process is DEXPI process, as I said, for block flow diagrams and for process flow diagrams. And our first big module was for P&ID, DEXPI plant. Now we use these names. In past, we had only DEXPI and meant, okay, that's the P&ID, but to have a good view on it, we have DEXPI covering both process and plant. And for the purple and for the pale blue world, we from DEXPI, we have no specifications. We try to align our specifications with the specifications here in this area. Let's say we are not able to cover the whole life cycle, but we try to cover these two important areas with our DEXPI specifications. And our starting point now 12 years ago was illustrated in this picture. We have different P&ID tools, and what we do in between by if we use an EPC from the view of an owner operator, EPC has another P&ID tool, and this kind of working was done by owner operator or by EPCs. And to bring this to a better kind of working, that was the first big task for DEXPI plant. Let's say how we tried to solve this task. We try to think global. it was started by, let's say, perhaps some German owner-operator like BASF, Bayer, and Evonik, but all these three companies are acting worldwide, and therefore we said, okay, we have to think global. And we started with a limited scope. And in that way, we know ISO 5926 Part 4 was an important reference data library, and from the beginning we had this in mind. And we worked together since the starting points with the important CIE vendors, and they said, okay, for us at that time in history, Proteus scheme is the best specification for transporting it. That are our big points which we try to cover. ISO 5926 and with Proteus, perhaps some of you know Adrian Lord with his XM plant, and we involved all CIE vendors. We use existing standards. That's important to know. We try not to reinvent the wheel. We had a bottom-up approach, and as I said, to be international, or let's say to be global, was a starting point at the beginning and important for us. That is our typical P&ID we always had for our discussions, and if we have a look on this kind of P&ID, we see, okay, here are the three main, let's say, disciplines or groups from plant items. We have piping and instrumentation, how it's in the name, P&ID. And what I didn't understand is the main things in the P&ID were the apparatus and machines, but not covered in the name. Not important. And we see the world of P&ID, the world of the engineers is there are symbols, there are labels, and of course there is a lot of engineering content in the P&ID. The whole topology of the plant is illustrated and covered by the P&ID. And we see some typical things from P&ID. Some were more from the older time, from documents. That is the world of off-page connectors. We have some kinds of annotations, and most P&IDs have a kind of title block. Let's say master data, which were important perhaps for the breakdown structures. And that was a task 12 years ago to define transport standard for P&IDs. And important to know, it is a transport standard and not a standard how to make the best P&ID in the world. And we developed some design principles, openness and transparency of the data model. We have test cases, and we communicate everything in our community. We try to use international accepted standard, and which was the important one I will show you on the next slide. Relations to different life cycle aspects is always important, that we know where we are and we say, okay, we cover the blue and the green part in the middle of our life cycle thinking. That means the structure for the plants. And important to know, we have a separation between engineering content and graphics. And the order is important. The engineering content was the main driver of our thinking, not the graphics, the old world, let's say, of symbols. Of course, we have to cover it, and how I will explain. And we use UML concepts like specification and decomposition for modeling the engineering and plant objects. That were our main principles for our design. And now let's go to the international standards we use. We found that the plant structure, there are important definitions in ISO 209. For apparatus and machines for P&ID, we found that there was specifications, ISO 10628, I think it's part 2, and the same it's for piping. There are groups and the symbols are groups, and our specifications, they are based on this kind of groups in that world. In the instrumentation world, we have used the IEC 62424 for the more blue part, for the functional view, and more for the detailing view, a little bit IEC 61987. And for communication and as reference data library, we use part 4 from ISO 5926 and the Proteus scheme, which was formerly known as Exemplant Adrian Lord. Very important to know is we use this standard, but it is applicable for IEC, ISA, DIN-based P&IDs as well. It is not restricted that you must use or have to use this standard in your P&ID configuration. It is important for our transport standard. And we try to cover all the different standards which were used for P&IDs. That is very important to know. Based on international standards, but try to cover other standards as well. And let us have a look at the different points here, perhaps from ISO 10209. We found some definitions. We had a look at the ISA world. We had a look at the ODIN world, and we said, okay, we use in our breakdown structures, of course, at the top enterprise. And then we have the sites. And then there are industrial complexes, and the industrial complexes, they contain of some process plants, and that is the middle of the thinking. And the process plants, there are plant sections, and we know in the ISA world, the plant sections has a little bit other name. It has the name process unit, and that is the same. And below we have the different kind of plant items for apparatus, machines, for piping, for instrumentation, for electrical, and so on. And we support additional structure things, and area is important as a subset for geographical parts from the plant. And what is not here, we have additional things like we support systems and trains in the structure as well. And the major parts in the breakdown structure are process plant and the plant items. Let's have a small look on the apparatus and machine taxonomy. We use, as I said, the groups from ISO 10628 with its 21 groups. And we said, okay, for that we have vessels, pumps, heat exchanger, and so on with the color blue. That is, let's say, the functional design level for a plant. And then we say, okay, there are subclasses for pumps, and that is well-known centrifugal pumps, oscillating displacement pumps, and some other types. That is the level in green for the asset specifications. That are the subtypes of the functional design objects. And then we saw, okay, sometimes we have to go a little bit deeper. And this kind of thinking, how deep we should go, is perhaps we should have it here, that is based on the maintenance standard for oil and gas, that's ISO 14224. ISO 14224 has, in our view, two important concepts. One is maintainable item. That is, we have to look at impeller, displacer, nozzles, gearboxes, and so on. And the other concept from ISO 14224 is the boundary concept. Which components belong to which apparatus and machines? There are answers in the concept from ISO 14224. And these two concepts are main design principles we use as well in DEXPI. What we didn't use from ISO 14224 are the different tables, which are, let's say, in the as examples in the appendix of ISO 14224. And then we go, okay, we relate the component to the highest level in the hierarchy, which is possible. That is a small picture of our apparatus and machines concept we use. And for all these objects we see here, we have definitions, and we use the reference to ISO 5926 part 4, and now edition 3 is released since some weeks, and we have references to that, and that is our important reference data library. And have a look at the piping taxonomy. The piping taxonomy also based on ISO 10628. We found there in that specification that there are 4 groups. One is for valves, one is for check valves, 23 is for valves and fittings with safety functions, and 24 is for fittings. Yes, we know there is a discussion for 23 that more from the ISA thinking 23 is not under the roof of piping. It should be more related to the discipline instrumentation. But we use ISO 10628 concept, but it is not important which discipline handles it. We have a look at the topology, and we cover both concepts, if it's related to the instrumentation discipline or to piping discipline. Not important, but important to know that is here in the part. Safety valves are in the part of the piping taxonomy, and for that we use based on ISO 10628. And here we have the several different groups, the valves for ball valves and so on, and for the different kind of fittings. We cover all the objects which were defined in these 4 groups of ISO 10628, and we found some more in different projects, and we added them. And perhaps in CFOS we have some more, and we will add them. Good. Instrumentation, that is, let's say, the discipline where it is very difficult to design a model, and we had heavy discussions, but since I think this solution is from 2016, and this solution we think cover many of the different standards which were used, including ISA standards. We have the blue thing, the functional model, which is more based on 62424, and more the green is more based on IEC 61987. And in the middle, as we have here the pictures, we always have the bubbles, and the bubbles were represented by process instrumentation functions. That is a term from ISO 5926 part 4. In IEC 624/24, the name for this is PCE request. But we have a common view, let's say, different terms for that. And then for the different bubbles, we can put them together to loops, and we can say, okay, there are different children possible for a bubble that is sensing something. We have process signal generating functions, and for actuating, we have the actuating function, and we have signals between, and to cover the actuating electrical functions as well, perhaps for frequency converter or to control heat insulation things. We have the additional part for actuating electrical functions as well. And these functions were implemented by systems. And these systems, they contain the typical parts. Yes, here is primary element that was from the ISO guys. They said 6 years ago, the best name is primary element. I think, oh no, now we know that measuring element would be a little bit better. And here is the transmitter world. And for the actuating systems, we have the different components like the controlled actuator, the control valve, the positioner, or perhaps the solenoid valve, and so on. And these green things, they were represented by symbols. Here we see perhaps an example for an actuating system. And we tried at the beginning to do tests that this model covers, let's say, the IEC world, let's say the ISA world, or let's say examples in the DIN world, and so on. And we know nearly every company or every region has its own standards, especially for the world of instrumentation. Okay. I said something to symbols, and I know in the Norwegian community, the NORSOC standard Z004 is important. And we know DEXPI is data-driven, a data-driven standards. But symbols we also consider, but not as primary part, only a secondary part. We can relate symbols to every instance of an object. And we found that there are two standards how to handle symbols. And that one is IEC 81714, the part 2, and the other is ISO 15519. And in these two standards, there is a definition that a symbol can be identified by 4 parts. First is the domain, second is a symbol number, third is an orientation, and fourth is the version. And here I have and with this concept, it is important that with the DEXPI concept, it is possible to change symbols from export the point ID and import the point ID. Here is an example for a centrifuge, and this example is from NORSOC standard, and it has the number PE030A. The orientation is an abbreviation for and has 8 possibilities. Let's say A is that one, B is the same symbol but turned around to the left. turned around to the bottom is C, and D is turned around to the right, and the other 4 letters are for mirroring examples. That is defined, I think, in one of these standards, how the orientation is defined. And if we have a look at the centrifuge symbol for in ISO 10628 part 4, it looks a little bit other. It has a number, it has an orientation, and it has a version. And with this kind of referencing symbols in the standard, it is possible that symbols can be exchanged in the way from export to import. And it is possible that with mapping tables for symbols to classes, it is possible that every company can use its own symbols. One thing which we have to consider a little bit, of course, we have to look, if we change symbols from export to import, we have a look at the connection points, if they are still valid. That is an additional task. But important that we try to use different symbol concepts to cover with DEXPI the different kind of P&IDs, if they are historical or if they are actual or if they are using this standard or that standard. Important to know. And what I hadn't in my presentation, we have a concept for a label in a similar manner for the important labels. In every company, we have different definitions. What is the content of piping network system label? Which 4 or 5 properties or the value of this 4 or 5 properties should be included? We said, okay, that's possible that every company uses its own label world, and we defined every label as a class. And then we say, okay, this label is that class, and then by importing a DEXPI P&ID, you can say, okay, will you use the definitions for label from the exporting tool or my internal importing structures? That is possible to change the different definitions of labels as well. Nearly the same, let's say, flexibility for symbols and for labels which were covered by the DEXPI concept. And what are our deliverables? We have the DEXPI specification. In the first, now we have version 1.3, and the first release appears 6 years ago. We use the extension of the Proteus scheme. We have a lot of tools and test cases. We have interfaces. Nearly every leading CAE company has interfaces for the P&ID software for importing, for exporting, for importing. And that, I hope, it's the right list of software companies which we work together. And some of our deliverables here are the specifications. Internally, as I said, it's UML. We can export this as XML file. And this internal things were converted to HTML. You can use this address to explore the whole data model. And it is also published as PDF. And here are 2 screenshots, one from HTML and from HTML and one from PDF. Important, our specifications for every CAE vendor and of course for every user for their own mapping tables. We have also tools in the DEXPI world, important that there is a viewer for a DEXPI file and a verificator. If the verificator verifies if the content of DEXPI P&ID is valid in the view of the DEXPI specification. It does not check if it's a good P&ID or not. That is the task of the engineer. And we have a sandbox for additional definitions which were not covered by part 4. Of course, part 4 is for DEXPI, the primary reference data library. And we can explore this data sandbox as well. But the important definitions are all here. Here are some extensions. And we have a code data and specification repository, which we use for our work, for our internal use, and we have a graphic builder as well. That is a little snapshot on the possible tools which we have in DEXPI. And the typical use case for DEXPI is to exchange P&IDs from, let's say, owner-operator to EPC, and of course, hand over back as a full data-driven standard. But there are additional more use cases, and many of these use cases were implemented in different companies. We can have interfaces to other disciplines like instrumentation, detailing, like process simulation, like the 3D piping world, that we can have a look. Do we have the important objects which we have on the P&ID, were they in the 3D as well? We can use the solutions for more for virtual reality. We can use it for mobile solution. We can use it for the safety systems, and we can use important if we have a complete P&ID world after the engineering task. We can start with perhaps a maintenance system and create all the structure we have in the P&ID, the topology. We can define this. Perhaps in the typical example is SAP plant maintenance. We can define with the input from the output from the P&ID world with the DEXPI concept. We can generate the whole structure of functional locations in SAP. Let's go to the second specification. The DEXPI process addresses a blind spot in the standard landscape. I do not know if David Cameron, the main author from this concept, is in the call. He is the main author from this concept, using all the concepts from DEXPI plant. And for this part, in the, let's say, in the first phase of the asset plant life cycle, there was no standard. And this is now covered by DEXPI process. And DEXPI process was started 2 years ago. And it covers not the P&ID, it covers the block flow diagrams and the process flow diagrams. And this process model is based on this specification and covers that. And we saw what I tried to explain before is the P&ID with the piping and instrumentation diagram, and that's for the plant model. We use for both the same concept, and this is now the, let's say, the brother or the sister of the plant model. Now we have an additional, the process model. And this process model covers the world of the calculated streams with the material template and with all the components of the streams and all the things which were covered here, and the input from that also with the principle to use standards which were implemented with Cape Open and Onto Cape. Based on that, David designed this model, and there is a hierarchy of the process steps. The process steps, what must be done, and then how it should be done, and that is a little bit deeper the level, and that is the level of the unit operations with the component systems. And here we see the upper part is more for the block flow diagrams on that level, and the lower part is more for the level of the process flow diagram. And here we have the typical things we need, perhaps for heating, cooling, heat exchanging, separations, and so on. And that's all covered by the DEXPI process definition. And the classes we have here are also classes from part 4, which, as I said, is our main reference data library. And the last year we published the result of this project, and everyone can have a look at this first manual. And we have this as a release specification, now 9 months old, and David has a very good publication about DEXPI process, which can be used to understand more the concepts, and David here is the main author of this publication. And now the next task is, and that is a task for Gregor and for the world of the content and handling the specifications. We have 2 specifications, and now we will build a common specification for both. And this one we use, as I said, here in the plant world, we have Proteus, and I think it's not official, but I think XM Plant or Proteus will be more history, and newer serialization formats will be cover both in one release, DEXPI 2.0 and both. And with that release, you can use both models, or you can use one model, or you can use the bridges between the model, let's say how the pumping is implemented here in the plant world. That is an overview from my side about the DEXPI specification world, DEXPI plant, the first important thing, and the second DEXPI process. And in next year, it will be one information model with one serialization, and that covers both. And I have a look at the watch. I think I will use some minutes more to explain what we will do with IDO together and with Cyphos. And then, Niels, I think we have time for questions as answers as well. Is it okay?
Yes, that's okay.
Good. Thanks. And then, yes, we defined a pump life cycle story from process to process plant, and what's not on the picture to assets. We have an example defined, and now we try, that is IDO use case 7, and we try to solve this use case with the concepts from IDO. And yes, it's not so easy to do it, but we are on a good way, and with support from Torbjörn and especially from Dirk last week, we had first solutions for some of these things, but we have to continue the work to solve this use case with IDO concepts. And what we will do more is, as I said, we will continue the work with this use case 7. And we have the two ontologies under the core ontology from IDO, and some of the process definitions we need for DEXPI process were in that process ontology, but not all, and we should try to populate it with all we need. And the same is from DEXPI plant. There is the corresponding ontology in IDO equipment, and we should try, several are in, but not all, we should try to populate all needed classes in that ontology. And what we have done for DEXPI, it is also possible for CIFOS. CIFOS is the important initiative. I do not know how old this initiative is. It's now since, I think, 4 years under the roof of IOGP, and the years before it was under the roof of USPI, and it is a handover specification, oil and gas handover specification. First, in the first years, it was more document-driven, and now it is more data and data-driven. And there is a huge community, and on the next picture, we see the different kind, and here we see perhaps from Norway, we see here Equinor, we see AKVP, and we see other IOGP members. We have other non-IOGP members from the process industry here as well. And we have a huge world of the CAE vendors, software vendors as well. We have EPCs here, and also we have some equipment suppliers here in the membership of CIFOS. CIFOS is under the roof of IOGP, and it is in the web, it is called the number 36. And the key deliverables, key elements are the whole world of documents, what is CIFOS, and the technical specification and the process guidance document. And important two other deliverables are the data model and the reference data library, and nearly the same concept as DEXPI has to use as primary reference data library ISO 5926. The same concept is used by CIFOS as well. And here is a little screenshot how the data model looks like. And you can see these things all in JIP 33, the joint initiative programs from IOGP. Number 36 is CIFOS. Here we see the process world, and where we have the process plant and the asset world as well in CIFOS here, and that are the most populated and handled things. The process is the youngest child and not so much populated. CIFOS first concentration is on, they call it tech, and they call it equipment. And with this tags in the process plant world, we have an alignment project to align this part for the process plant with the DEXPI definitions. And the result is a look at the newer CIFOS release version 2. They have 850 tag classes. And we had a look at the first 3 main disciplines, about 170 apparatus machine classes, 95 piping classes, and about 200 instrumentation classes. And CIFOS says, okay, we have some from other non-traditional P&ID groups in our P&ID world as well, from infrastructure, health, safety, environment, and so on. And we started with the work with the 3 classical disciplines, or let's say groups, And we see that is an important amount. And we try to integrate them from CFOS in the DEXPI plant taxonomy. And we had a first look, and we will hope. Peter Townsend from CFOS, he said, okay, we should be able to finish our work for the 3 classical groups this year. We do a SCOS mapping, and after that we have done for the 3 main disciplines or groups, we will add, try to add the other in the taxonomy as well. But that is second priority. That is a little overview of our work, and here are 2 examples how it could look. This common taxonomy, for an example, the typical pump and the motor as well, how they are defined. In orange, more the CFOS definitions, and in green, the DEXPI definitions. And as we see here, the RDL2, let's say the ISO 59226 Part 4 definitions we have here. And that is a little view on our work and outlook, what we will try to get with our CFOS DEXPI alignment work. And this is a picture we use at our picnic conference, which we have every time when the ACHEMA in Frankfurt is, the global fair for the process industry. And here we see, here are all important players we have here from the post-CESA, from the Norwegian, or from the Nordic world, the THTH, SIA. We have from the US, IUGP liaison, we have ISO, we have IEC, CII, with Namur things. For the more instrumentation things, we work together. And for all who know about asset administration shell, the Open Industry Alliance is here, and for the asset administration shell, the IDTA, the company which is managing the submodels for the asset administration shell as well, where we should perhaps we always the BIM world, perhaps a little bit a gap in our alignment world, but that is the task for the future. And with this picture, I will stop my presentation, and I hope you have some questions.
Thank you so much, Heiner. Questions for Heiner? Door is open.
Hi, here's Teemu Mätäsniemi from VTT Finland. What kind of schedule you have for DEXPI 2.0 version?
I think Gregor is out. He has another meeting, but of course we should have in this year the serialization format. There should be a decision, and implementing is planned for next year.
Thanks.
Perhaps it was not on my slide, always the license question. There is no fee to use DEXPI. To be a member of the DEXPI association, yes, there are some member fees, yes. And there is an internal community responsible for development, and there is a member fee for that. And we have, you can use the DEXPI homepage. There is a special task for onboarding, how to be a member of DEXPI. That is covered by that onboarding team from DEXPI.
Okay. This is quite a large audience, so we cannot maybe not expect too many questions. But as I said, we will have questions and answer sessions, and how we can do that, I will send out some information about that next week. Are there any more questions for Heiner?
I have raised my hand, Nils. Just some reflections and maybe some questions as well. I think this was a very good start to both of you, Nils and Heiner. It's a comprehensive stuff that we are working on. It's a lot of standards to understand, or at least have some insight into. What I was wondering about is, do we have some data that we could share, DEXPI files that we could share in the community, so people can have deep dives into the data structures, have a look at it, how it may work in their applications or in their daily use? I think that would be fantastic. It might be some documentation on the DEXPI site already, so please inform about that as well.
Okay, Jan, thanks for the question. As you said in your question, you answered perhaps yourself. We have several documents on DEXPI.org, open for everyone. We have our specification, as I said, version 1.3. We have that as we can explore it in the web. It's open, and we can have the complete document as PDF. And there are several use cases in DEXPI, and these use cases are open, and the solutions as well.
Good.
Okay,
Thank you.
there's another question.
Yes, there is another hand raised.
But yeah, is that, I guess,
It's difficult to hear.
Speak a little bit louder?
now?
Yes,
Now.
much better.
My head, yes.
Thank you.
There was a lot of information coming through, and one of the things that I picked up was about the DEXPI 2.0 specification. Was that due by the 1st of 2025? Was there a timeline for that?
Yes, but that is not the major point. We have the specifications for both there, for DEXPI plant and DEXPI process. And both are specifications in UML. And this were only combined into a common. That is not a big task. To exchange Proteus with a new serialization format, that is the task. That's the main task.
Okay.
And there is an own project to select the serialization format. And as I said, so that the time for Proteus is over, and that there will be newer and modern formats for the serialization.
Okay. Thanks for the clarification.
Yes, okay. Martin, other questions?
I could mention also in the PVN project, there will be DEXPI data. That's for sure. From the use cases, there are at least, I think there are 3 use cases that will be using DEXPI for the exchange of data. So there will be data in PVN. The technology work packages, the results of those, they are open. But the results from the use cases, that is not automatically open. That depends on the companies that participate in those use cases, whether it will be completely open or not. So we will have to come back to that later. More questions for Heiner?
Well, maybe a final question from me, not directly to Heiner maybe, but to the community activities. Where will we start sharing the documents for the community that we would like to establish now? Will we have one page or one site, or will we be spread around using the link to the different standardization bodies homepage?
You're thinking of a community we try to establish now?
Yes.
We will try to have one place where you can go and look, and we will, at least in my head, we will have links to the standardization organization. That is not quite in place yet, so we need to. This is things we need to discuss in these meetings.
Very good. Thank you very much, Niels.
And there was one question which came in the chat, just to answer that also before we stop. That was about connection between BIM and IFC, and those standards, and IDO and OBI. At the moment, we don't have any activity on that, but it is on the plan for PVN project also, but it's not at the moment first priority. So again, this is something we will need to come back to.
And perhaps some additional answer at our picnic conference now in June in Frankfurt. There was a discussion about how to work together with the BIM community, with the IFC community as well. And I think in the work from Anders Thorstrup, we will try to set up this work as well. And there are always ideas. The BIM community has some different domains where they have the core domain, and there are some additional domains where they have definitions, and they say always we need 100,000 euro domain for the process industry, and then we are happy. I think this approach is not the best one. If we are to look at the typical pump example, we have related to the process industry several different types of pumps. And the only type of pump is a sump pump in the community of BIM. And that shows, okay, we will not be happy if we speak about pumps on the one side and pumps on the other side. I think we should be able to say, okay, in that world, the object definitions of BIM are primary, and in our world of the process industry, our process items are primary. And we should try to, let's say, reference domains and not new definition domains.
We are approaching the end of this this meeting, and people are starting to leave. So I think we've tried to do this prompt. Are there any burning questions before we stop? If not, please note that we will have our next meeting next Friday. That will be for 1 hour only, and it will be about the IDO. And we have a small group here. We will need to discuss how we can do this further. I will send out an invitation for the whole series of meetings. At least I will do that early next week. And the reason I didn't do it was that this is a meeting with an hour and a half, and the rest of the meetings will be for 1 hour. So that is what I have to say. Just ask the final question. Anything else we should talk about before we close the meeting? If not, yeah, go ahead.
I think this was a good session. So have a nice weekend, everybody.
Yeah, I would like to say the same. Thank you so much for showing up, and have a nice weekend.
Have a good weekend.
Thank you. Bye.
Have a nice weekend. Thank you.
Thank you. Bye-bye.
Thank you.
Thank you. Bye.
Thank you. Bye.
Bye-bye.
Bye.